Right, so the first thing we really need to address in this class before we start learning calculus is just talk about what is calculus anyway, because you've been told that it's different than the other classes that you've had before this, like Algebra 1 and Algebra 2 and pre-calculus. And it is. Calculus has a specific purpose in mind. Now, in order to understand that, I want to start with a couple of pictures. So I'm going to draw a picture of a graph, and that graph is going to be a graph of the equation y equals 5. Now, if I were to ask you the slope of this graph, of course you should be able to tell me that the slope of this thing is 0. And if I were to ask you, if I went from 0 on the x value to, say, 6 on the x value, you should be able to tell me what the area between this graph and the x-axis is. And you would say that's a rectangle. So width of 5, height of 6, and so the area is 30. I'm going to draw another picture. This time, I want to draw the line y equals 2x. Now, if I were to ask you the slope of this line, of course you would say, it's 2. I took Algebra 2, Mr. Cooper. If I talked about finding the area between this graph and the x-axis from 0 to 6, you would say, hey, that's a triangle. And the base of that is 6, and you might have to do just a little bit of mental math to figure out that the height of this is 12. And so half times 6 times 12 would be 36. Now, in and of themselves, those questions aren't interesting. However, when you start thinking about graphs as what they really are, which is representations of real life situations, pictorial representations of mathematical occurrences, things start to make a little more sense. Let me give you an example. So let's take this yellow graph and say that this actually is a graph that means something. It has context. The x-axis will represent time in hours. And the y-axis will represent speed. You could call it velocity. There is a slight difference. We'll talk about that later. In miles per hour. Now that this has context, this graph tells a story. And if you look at the line itself, it's saying that the y values, which are speed, is always 5. So this thing is traveling at 5 miles an hour at a constant speed. And it's doing that for 6 hours. Now, if we go back and talk about the slope, which you said, hey, that's really easy, and the area, which you also said is really easy, those now have meaning. The slope, which is 0, is how quickly the speed is changing in terms of hours. So in other words, its units would be miles per hour. And those of you who have had physics, you know we sometimes write that as miles per hour squared. Meanwhile, the area, it's traveled 5 miles an hour for 1 hour, for 2 hours, for 3 hours, for 4 hours, for 5 hours, for 6 hours. So if it's done that, that represents sort of like the distance it's covered. So this is 30 miles per hour times hours. Those would cancel and leave you with 30 miles. So essentially what you need to understand is when you have a graph that has context, the units of slope are the units of the y divided by the units of the x, and the units of the area are units of the y times the units of x. Same thing over here. If I came over to the blue graph and said, hey, let's make this x-axis time in seconds, and let's make this y-axis gallons per second. So this is sort of like a tank draining. Here, the slope would still be 2, but now it has units and meaning, and that would be gallons per second, which is gallons per second squared. The area would be 36 gallons per second times seconds. So 36 gallons. Now, in and of itself, this isn't calculus, but what we're about to do in the next video is.